Continuing with the Math 1314 Final Exam Review, number 61 asks, or it tells you to decide whether the pair of functions graphed are inverses. So are the red and the blue functions inverses? And they are inverses because they are symmetric with respect to the line y equals x. And you can see the dashed line here is y equals x, and that red and that blue function are symmetric with respect to that line y equals x. So yes, those functions graphed are inverses of each other. Number 62 says to write the expression as a single logarithm with a coefficient of 1. So first thing I need to do is combine and get rid of this minus and write this as 1 log base a. So I get log base a. How do I combine? I'm going to do t divided by s. So I have log base a of t divided by s. I still have plus. Now this coefficient needs to come back up as an exponent, and I get log base a of u to the fourth. Now to combine these two logs, notice that I'm adding. How do you make 1 log out of that? I'm going to say log base a of ts times u to the fourth. So I get the log base a of t times u to the fourth divided by s. Number 63 wants me to graph. It says to write an equation for the given graph. And here's the given graph. And it tells you that it represents an exponential function with base 2, translated and or reflected, but no stretching or shrinking. So my parent function, y equals 2 to the x, if I have x values of -1, 1, and -1, 0, and 1, my y values 2 to the -1 is 1/2, 2 to the 0 is 1, and 2 to the 1 is 2. Now I look at my graph and I have located these 3 points here. Sorry. Let's go do -2, -2, and -3, -3, and -4 down here. I'm going to see what that looks like. So if I started out with the original points here, here, and 2, 1. Sorry, let's do that again. I'm going to start out with the parent function, -1, 1/2, 0, 1, and 1, 2. And I want to move those 3 points. And I'm going to choose to move them down here. I've noticed -2, -2, -3, -3, and -4 something. That looks just like these 3 points. Okay, I have moved these points 3 to the left and down 4. So these new points become, subtracting 3 from my x's, I get -4, -3, -2. That's what I looked at on my new red points. Subtracting 4 from my y values, I get -7/2, -3, -2. So from my parent function, I want to subtract 3 from my x's. In other words, move them left 3. I want to subtract 4 from my y values. In other words, I want to move it down 4. So my new function becomes f of x equals 2 raised to the x plus 3. That moves it left 3. And then I want to say -4 because this moves it down 4. So there's my new function that's been moved. This function is graphed here. Number 64, I want to solve for x 3 to the 6 minus 3x equals 1 over 27. I notice that both the left and the right hand side can be written as powers of 3. So I get 3 to the 6 minus 2x, 3 to the 6 minus 3x equals 3 to the minus 3. I have a rule that says if a to the m equals a to the n, then m equals n. So I can get rid of these bases and say 6 minus 3x is equal to negative 3. Solving for x, I need to subtract 3 from both sides. I get negative 3x equals negative 9. Dividing both sides by negative 3, I get x equals 3. Number 65 says how much money will be in the account if $1,417.32 is invested for 6 years at 4% annual interest compounded monthly. It's a lot of information, but here we go. You want to invest $1,417.32. That is your P. You want to invest it into an account paying 4% annual interest, so our R is 0.04. And it is compounded monthly, so our N is 12. And you want to invest it for 6 years, so T is 6. When I type this into the calculator, I get the answer of $1,801.05. Number 66 says to evaluate log base 7 of 1 over 49. I realize that 1 over 49 can be written as a power of 7. Log base 7 of 7 to the negative 2. Now I'm going to apply the rule that log base b of b to the x is equal to x. Log base 7 of 7 to the negative 2 is equal to negative 2. Number 67 says to write the exponential equation in its equivalent logarithmic form. I have 8 to the 5/3 equals 32. To write that in logarithmic form, I want to do log base 8 of 32 is equal to 5/3. Number 68 says to solve the equation log base 10 of 0.01. So if x equals log base 10 of 0.01, I'm going to write 0.01 as a power of 10. So I have x equals log base 10 of 10 to the negative 2, because 10 to the negative 2 is 0.01. Okay, what is log base 10 of 10 to the negative 2? It's just negative 2. Number 69 says to sketch a graph of the function and give the domain and the range. The function is f of x equals log base 2 of x minus 1. I notice that is the parent graph is log base 2 of x, but this graph has shifted it to the right 1. So all my x values here for my parent, I'm going to need to add 1 to all those x values. Okay, my parent graph, y equals log base 2 of x. My three favorite y values are -1, 0, and 1. For my x values, I get 1 over the base, 1, and the base. Okay, for this function, I'm not doing anything to the y values of my parent function, so they stay the same, -1, 0, and 1. But my x values, I need to add 1. 1/2 plus 1 is 3/2. 1 plus 1 is 2. 2 plus 1 is 3. So my 3 points, I'm going to go graph on my graph, are going to be 3/2, -1, 2, 0, and 3, 1. Here's my graph. My domain, notice that the vertical asymptote is moved over to x equals 1. It's no longer x equals 0. My domain is going to be from parenthesis 1 to infinity, and my range is all real numbers. For number 70, I need to approximate log base 5 of 0.497. I can do that a couple different ways on my calculator. If I have a new operating system on my calculator, I can type in log base 5 of 0.497 and I get the answer, the approximation, negative 0.4344. If I don't have a new operating system on my calculator, I have to do the change of base and type in natural log of 0.497 over natural log of 5. Recall that the change of base formula says log base b of a number is equal to log new base of the number over log new base of the old base. So I could use base e and say ln of n over ln of b. And that's what I did here.